In this video we are going to talk about the implementation of Dijkstra algorithm in DIgSILENT Power Factory. So this algorithm was created by a Dutch researcher in which he solved the graph theory problem, in which he wanted to find the shortest path between two nodes in a graph. So for this I created a problem, actually a study case, in which we have these points placed in this fashion in the Cartesian plane. Each point is defined by its y and x and y coordinates, and between the nodes are the connection which is weighted. I mean, the connection has a value, being the distance between the nodes or the time in which we can go to from a node to another. So I just introduced these points, 15 points in the algorithm that I created in DIgSILENT, and the connections, and the algorithm is going to give me the path of 2 points. Actually, for this study case, I tried to find the distance between point 1 and point 7. So let's see how I did this. Okay, as I said earlier, we are going to try to find the shortest path and the distance between node 1 and node 7, for example. We can choose any points, but for this example, because I want to show you the step-by-step process, we're going to find out the shortest path between 1 and point 7. So I already introduced, as I said, the nodes and the connections between the nodes in DIgSILENT. Okay, so we have here number of vertices, number of nodes, 15. Those are parameters, probability of connection, because we have the possibility to create a random pattern of points. But in this case, we are not going to create a random path. I just already introduced the data for our network. Okay, start point and end point. Okay, so start point is going to be, as I told you, 1 and 7. So if I am running the algorithm, here is going to be created a plot. Yes, it's going to be created a plot with exactly at, like this one, and the shortest path is going to be drawn with the red color. Okay, let's see. Just press execute. Okay, so this is the plot. You can see that is exactly like this one. Okay, so we have here, this is node 1 and this is node 7. You can see that we have here the shortest path is node 1, node 2, node 4, node 11, node 10, and node 7. The length being, let's say, 10.67 kilometers, let's say. And here we have every step of the algorithm. Now we are going to run it several times, step by step, in order to see how we got this shortest path. First, let's present the matrices that are behind the algorithm. So, but first of all, I introduce another variable, breakpoint. I'm going to show you what this does. Okay, later. So in content we have all the scripts and matrices which we are working with. So the distance script is going to compute the distance between all the nodes. Dynamic res plot is creating this plot. Okay, so we have coordinates. Coordinate is a 2-column matrix with the coordinates of the nodes, the x and y coordinates of every point. Okay, then we have connection matrix. Connection matrix of 15 by 15 matrix, in which it shows the connection between nodes. So between 1 and 1, obviously it's 0. Between 1 and 2, we have a connection, so it is 1. Also the same in for node 2, 1 is we have 1 here. So we are going to notice that this matrix is symmetrical. Okay. Next matrix is a distance matrix, in which there are computed the distances between every point. Okay, so it's a 15 by 15 in this case matrix. Is computing it is computed the Euclidean distance. So for instance, between 1 and 1 is distance is 0. Between 1 and 2, the distance Euclidean distance is 1.4144. The same distance from node 2 to node 1 is the same. So like previous matrix, is a symmetrical matrix. Okay, further now we have now I'm going to show you the most important matrix. So Dijkstra matrix. We have here a matrix with 15 rows and 4 columns, in which in first row are the names of the nodes 1, 2, 3 till 15. Second column is the distance to every node from the starting node. So from 1 to 1 is distance is 0, obviously. From 1 to 2 is 1.4142. From node 1 to 3 is 2.236, so on and so forth. The third column is the column in which we have the information that if the node is visited or was visited or not. We can notice here that all the nodes were visited because we just already run the algorithm. And finally, the last column is about the previous vertex. So for node 2, the previous vertex is previous node is 1, so on and so forth. Okay. To see every step of the algorithm, first we must create a breakpoint in order to see the initial Dijkstra matrix. Go in scripts. Okay, in here, and uncomment this. So the algorithm will stop here. Save and execute the script. Okay. So let's go in the matrix content. So initially the Dijkstra matrix have this format. So for starting node 1, we have the shortest distance is 0, because it's set to 0 because that is the starting point. All other distances are set to infinity because they are unknown, and gradually with every step they are going to be updated. The same in the third column. Once we visit a vertex, we are going to make them value 1 in the third column, and in the last column, in the fourth column, we are going to put here the previous node. As a general rule for the algorithm of choosing the starting point or the next point is just to consider the point from the matrix. Okay, consider the point from the matrix which is not visited, yes, and has the smallest, shortest distance. Yes, so in this case, this node is 1. Yes, because it's not visited and has a value of 0. Okay. Further, we are going to go in the script, and we are going to comment this breakpoint. Okay. And now we are going to put here at the breakpoint 1. This means that the algorithm starts after visiting the the first node, in this case node 1. Yes, node 1. Okay, now execute. Okay, we can see that the starting point is 1, as I presented you earlier, and the adjacent points are 2, 3, and 5. Let's see the adjacent points. So the near points are connected points are 2, 3, and 5. Now we're going to go in the content of the script in the matrix to see what happened. So for first point, because it is the starting point and we just visited, we have here in the third column 1. For the first adjacent point, we have the shorter distance have been updated, because the distance between the starting point and 2 is 1.4142, which is much smaller than the infinite value that he previously has, and the starting and the previous vertex is 1, because we started from 1. The same in the case of the point 3. Point 3 is the same. The distance from 1 to 3 is 2.236, and also previous vertex is 1. Yeah, we updated this value because it's much smaller than infinite. The same in the case of 5. We put here in the instead of infinite the distance 3.162 and previous vertex 1. Now the algorithm repeats itself. So the next node that the algorithm is going to visit is going to be 2. Why? Because is the node with the smallest shortest distance, which is not visited. Yes, because it has a distance of 1.41, which is the smallest. Now we are going to create a breakpoint when the algorithm arrives in the second node. So we are going to put here 2. So we are going to execute the script. Okay, so as I showed you previously, the next point is going to be 2. Yes, and the distance, dVertice, the distance from starting point and 2 is going to be 1.4142. Okay, let's look inside of the matrix to see what is updated. So we're going to take each point. So the first adjacent point is 1. Here nothing happens, so we cannot update here because this node was visited. Okay, then we're going to take the point 4. Point 4 here. You can see that the shortest distance for point 4 has been updated. So as a general rule, how we are going to update this shortest distance. The shortest distance is updated when the sum of the distance between starting point and the next point, which is dVertice, and the distance from next point, which is 2, and in this case 4, sum of these two values, 1.41 and 1.41 here, is going to be less than the distance that was previously here. So here was previously infinity, so we have 2.82, the sum of these two distances. Yes, and the next and the previous vertex is going to be 2, because we are already in node 2. Okay, so we're going to go to 6. The same thing applies here. So if you're going to 6, we're going to see that like previously, we have here 4.4142 instead of infinity. Is the same rule. So we are going to update this value from here if the sum of the vertex plus dx is going to be less than the previous value from here. so it's less than infinity, of course. So then we have here 3 plus 1.4142. Yes, the sum of these two values. Once again, I repeat myself, the distance from starting point to the next point, from 1 to 2, add with the distance from point 2 to 6 in this case, which is dx. And of course, finally we are going to update the previous vertex, which is 2. The same thing in 14. Yes, let's go in 14 to see. Yes, it has been updated in the same fashion. Here previously was infinity, so the sum of these two distances, 1.41 and 8.062, is smaller. The sum is smaller than the infinity, so have been updated here, and with the previous vertex 2. Now, as mentioned earlier, which is going to be the next point that the algorithm is going to follow. So let's see. The rule stated like this. So it's going to be the unvisited node with the smallest shortest distance. So it's going to be 3 in this case. Okay. Moving forward, so we are going to create a breakpoint when the algorithm will arrive in the third node of the graph. Save and execute. Okay, we are going to see here that the next point is going to be 3, as I mentioned earlier, and the distance between from the start point to the next point to 3 is going to be dVertice, which is equal to 2.23, and the adjacent points are 1 and 4. Let's look a bit on the graph to see this point. So we are here in the node 3, and then adjacent nodes are 1 and 4 with the distance of 2.23 and 2.23. The distances are equal. Okay, now let's see what have been updated in the matrix. Once again, how to update the shortest distance. The shortest distance is updated only if the sum of dVertice plus dx of a point is smaller than the previous value from the shortest distance of that particular point. So for point 1 was visited, so here no update here. Second point is going to be 4. Here 4 is not a visit, was not visited, but is not been updated because the sum, once again the rule, the sum of dVertice and dx is smaller than the previous value. Previous value is being 2.8284, so the previous value remains here, as well as the previous vertex. Once again, I repeat myself, dVertice is the distance between start point and the next point being 3, and dx is the distance between next point 3 and the adjacent point, in this case 1 or 4. Okay, and further we're going to apply the same rule, how to choose the next node is just the unvisited node with the smallest shortest distance. So it's going to be, let's see, maybe I'm not mistaken, so it's going to be 4. Okay, let's see this. Okay, we are going to put here 4. So the algorithm stops when it arrives in the 4th node. Okay, yes, indeed, the algorithm choose the bus or the point 4 as the next point, and all the rules are applying the same as previous. And finally, we are going to remove this breakpoint in order the algorithm to work till the end. Okay, so once again, we can see the path from 1 to 0.7. The path is 1, 2, 4, 11, 10, and 7 with a length of 10.67. Okay, so let's see in the matrix how we determine the path. So we're going to go in content, this matrix. So we are going to start from the endpoint. Endpoint is 7. Okay, as we introduce here. So 0.7, so is the last point. Then the previous point is 10. Here it is. Now we're going to go to 10. The previous point is 11, so 11. Now we're going to go in 11, so the previous point of 11 is 4. Okay, so we're going to 4. The previous point is 2. We're going to 2. The previous point is 1. Okay, so in this way the path has been created. Okay, thank you so much.